Our third equation is an absolute value equation. To solve an absolute value equation, we want to go ahead and isolate the absolute value and then get rid of it, because the absolute value is kind of containing things and it's preventing us from kind of manipulating the stuff inside. So we need to get rid of the absolute value eventually. But you should never do that until you've isolated it. Right now, we have a 3 that's multiplying the absolute value, and we have a -1 that is on the outside, subtracting 1 basically from the absolute value term. We want to get rid of both of those. Generally, we are going to take care of moving anything that's added or subtracted first and then divide out the thing that's multiplied. So we're going to have 3 times the quantity 2x plus 3 that's inside the absolute value. Add the 1 to both sides, so we get 21 on the right side. Now we're going to get rid of the 3 by dividing out the 3 from both sides. So 2x plus 3 inside of the absolute value is equal to 21 over 3, which is 7. So now we have an absolute value equation where the absolute value is isolated. All right, at this point, we're going to go ahead and split this into 2 equations. We do that by considering that this absolute value is saying we have a distance from 0 of 7, and that means the stuff inside is 7 units away from 0 on the number line. Now you could go to the left side on the number line, and that would be a -7. Okay, or you go to the right side of the number line, and that stuff could be +7. Basically, the idea is you take the inside and set it equal to the positive and the negative of the constant on the left side. So we actually get these 2 simpler equations, no square absolute values left. And now we can just go ahead and calculate, isolate x with each one. So 2x plus 3 equals -7. We're just simply going to subtract 3 from both sides, so I get 2x equals -10, and then divide out the 2, so x equals -5. So there's one solution. 2x plus 3 equals 7, going to the other equation, subtract the 3 from both sides, 7 minus 3 is 4, and then divide out the 2, 4 divided by 2 is 2. So we get 2 solutions. Now, you can have extraneous solutions in absolute value equations, so it is important that you check your solutions before you say they really are solutions. And let's take a look at these. If we put the -5 in, the 3 times the absolute value of 2 times -5 plus 3, close the absolute value, -1, is that equal to 20? Notice I'm checking the original equation. Always check the original equation. We know we have 20 on the right, so we really just have to calculate the left side. Well, I have to do this in order of operation, so start with the inside of the absolute value. 2 times -5 is -10. Then we're going to have to add 3 before we finish that up. If we add 3 to -10, we get a -7 inside the absolute value. And then continuing on, the absolute value of -7 is +7. And then 3 times +7 is 21. And finally, subtract that 1, and we've got 20. Notice that -1 is the last thing we do. We kind of have to just pull it down the whole way. So now we have 20 equals 20, and that is true. So that checks. And then we can check the other value of 2. 3 times the absolute value of 2 times 2 plus 3 minus 1, is that really equal to 20? Well, again, check this left-hand side, 3 times the absolute value. I'm going to go a little faster on this one. 2 times 2 is 4, plus 3 is 7, so I have the absolute value of 7 on that side. And then on the, if I continue, 3 times the absolute value of 7, well, the absolute value of 7 is 7, so 3 times 7 is 21, minus 1 is 20, and we get exactly the same value on both sides of that when we check that value as well. So we do have 2 solutions here. Both of them do work. So the solution set will be written as brace -5, 2, end your brace. So solving an absolute value equation, make sure you isolate the absolute value first and then split it into 2 simpler linear equations. All right, here's an equation. 5 times x minus 4 equals 5 minus 2 times the quantity x plus 1. This equation is linear, but it can, because we don't have any square roots, absolute values, fractions, and there's no x squared terms. And in fact, we want to consider that there might be if we do the distribution, but even when we do the distributions, 5 times x is 5x, 5 times negative 4 is negative 20, and then distribute the negative 2. Negative 2 times x is negative 2x, and negative 2 times 1 is negative 2. Still no x squared term, so this is just purely a linear equation. To solve a linear equation, we're just going to get x by itself. To do that, we need to have x's. If we have multiple x terms, they need to be on the same side so we can combine them. In this case, we do have multiple x terms. We have a 5x and a negative 2x. Before I do that, I do have some like terms to collect on the left side, or on the right side rather. So let's do that. 5x minus 20 equals 5 minus 2 is 3 minus 2x. So always try to simplify each side. Keep the equations as simple as possible as you move through solving it. Now let's move the x terms to one side. Generally, when you have two x terms, you want to move the one that is smaller, in that case negative 2x. We move it over, we're going to add it to both sides, so we're going to get 7x minus 20 equals 3. Next, move the constant to the other side, so negative 20 moves over, we add 20 to both sides, so 7x equals 23. And then divide out the x from both sides. So we get x equals 23 over 7. So we're dividing by 7 to get x by itself. So our solution, it looks like, is 23 over 7. Unfortunately, that doesn't come out to a nice whole number, but we can deal with the fraction. Solutions can be fractions. Let's check this to make sure we haven't made a mistake along the way. When I check it, I'm going to plug that fraction in. And if you want, you could use your calculator to check by making that into a decimal and then checking it in there. I'm going to practice the fractions because I think everybody can use extra practice on fractions. So I'm just plugging 23/7 in wherever I see x in the original equation. You must go back to the original equation. And then we're going to take our time and calculate the two sides. I'm going to start on the left. So always work with order of operations. So we're going to have 5 times, we need a common denominator, and that will be the 7. So I'm going to get 23 over 7 minus, and I'm going to multiply that fraction of 4 over 1 by 7 on both top and bottom. So I'm going to get 28 over 7. I changed colors there. Let me go back to green. And then I can now subtract the values inside the parentheses. 23 minus 28 is negative 5 over 7. And then I can finally multiply that 5 that's on the outside. When you multiply a whole number by a fraction, remember the whole number is over 1 and you multiply straight across. So negative 25 from 5 times negative 5 over 7. So on the left side of this equation, I end up with a value of negative 25 over 7. Let's see if we get the same thing on the right. 5 minus 2, take care of the inside values first. Now I have 23 over 7 plus 1. I need a common denominator. 1 can be 7 over 7. So I'm going to write that as 7 over 7. And then I can add those fractions together. So I have 5 minus 2 times now 30 over 7, because I add the numerators, keep the common denominator. Next, I'm going to multiply by this 2. Remember, when you're multiplying by a whole number by a fraction, make that whole number into a fraction. So 5 minus 60 over 7, and then get a common denominator to do my final subtraction. So I'm going to need a common denominator of 7. So now I have 35 over 7 minus 60 over 7, and then subtract your fractions. 35 minus 60 is negative 25 over a common denominator of 7. That's exactly where we were. So that means that the solution was correct, and our solution set is just simply that single value of 23 over 7.